Alright, you guys, this is video E3.3-9, the beginning of section C here for E3.3, and this says describe the motion history of geologic features. The example of plates in Hawaii is being used here, using equations relating rate, time, and distance. So we're going to be talking about here the notes for Hawaiian Islands formation, and we're using this example to relate how the plates have moved over the hot spot that's creating the Hawaiian Islands over, or I guess during a certain amount of time. Okay, so how far is it moving over time? So that's the rate we're looking at here. This will sort of prep us to get into the next activity, actually dealing with some of these calculations that we're going to look at. But again, this is a Khan Academy video, so follow along and use that pause button when you need to.
We've talked a lot about the formations of mountains and volcanoes when plates are running into each other or where one plate is being subducted under another. But that isn't the only place. It is the dominant place or the most likely place to find mountains or volcanoes on the surface of the Earth. But that's not the only place that mountains or volcanoes can form. And probably the biggest example of volcanic activity, or the most popular one, this might be a slightly Amero-centric point of view, but the most often cited example of volcanic activity away from a plate boundary is Hawaii. Hawaii. So this right here, these are the Hawaiian Islands. This is the big island of Hawaii, and it is experiencing an active volcano. Lava is, or magma is flowing from underneath the ground, and that once it surfaces, we call it lava. And that lava is actively making the island bigger. So where is that volcanic activity coming from? And then how can we think about that volcanic activity or that kind of heat rising from below the surface of the Earth to explain some of the geological features we see around Hawaii? So what we think is happening, and once again, this is all theory right here, is that Hawaii is sitting on top of a hotspot. In particular, the big island of Hawaii is sitting on top of the hotspot right now. And this hotspot, there's different ways, different theories on how it might emerge, but we think that at the mantle core boundary, and I don't know in this diagram whether they intended this white area to be the core, but let's just say that this is the outer core down here. Let's just say that this is the outer core. Outer core for the sake of explaining things. It's possible that kind of plumes of very hot material can kind of, just based on kind of the fluid dynamics of what's happening at that mantle outer core boundary, that plumes of really hot material can kind of rise up, let me do this in a darker color, can rise up from the outer core. They would rise up from the outer core and then create hot spots underneath the moving lithospheric plates, underneath the plates. Now, it's not we don't know for sure whether the hot spots are being created by these mantle plumes, this material formed or heated up at the outer core mantle boundary. But what we do feel pretty confident about is that there is this hot spot here. And it's independent of any of those convection patterns that we saw. I shouldn't say independent. It's obviously all related because we have all this fluidic motion going on in the mantle. But it's separate on some degree from all of those convection patterns that we talked about that would actually cause the plates to move. And to a large degree, or the way we think about it right now, this is stationary. This hotspot is stationary relative to the plates. And the reason why we feel pretty good about thinking that it's stationary relative to the plates is we see this notion right here. If you look at the volcanic rock in Kauai, which is one of the older inhabited Hawaiian islands, the oldest rock that we've observed there is 5.5 million years old, and it's all volcanic rock. Now, the oldest rock we've observed on the Big Island is about 700,000 years old. We also know that the Pacific plate, you could look at this diagram right over here, is moving in this general direction. In fact, we know it from GPS measurements. It's moving exactly in the direction that the Hawaiian Islands are kind of distributed in. So, frankly, the only good explanation for why we see this pattern, why we see newer land here, and then as we go further and further up the Hawaiian island chain, we see older and older land. And actually, if we keep going, we have the Leeward Islands over here, and as we keep measuring the rock on the Leeward Islands, they get older and older as you go to the northwest. And then if you even look at what's below the ocean, this is the big island of Hawaii. These are the main Hawaiian islands. These are the Leeward Islands. But you see, even beyond that, submersed under the Pacific Ocean, you continue to see a chain of islands. So the explanation for what's happening here is that you have a stationary hotspot that is right now underneath the big island of Hawaii. And I just want to be clear. The big island is called the island of Hawaii. It is one of the islands in the state of Hawaii. So I don't want to cause you confusion. So I'll just call it the big island from here on out. So the hotspot is right under the big island. But if you were to rewind 5 million years ago, the entire Pacific plate was probably on the order of, about 150, 200 miles, however far Kauai is from the big island. It was probably shifted that much to the southeast if you go back 5 million years ago. So 5 million years ago, when all of this was shifted down and to the right, then Kauai was on top of the hotspot. And so this is how each of these islands are formed. If you rewind a ton of years, then maybe this area over here on the Pacific plate was over the hotspot. An island formed there. Then the Pacific plate kept moving to the northwest. It kept moving to the northwest, and new islands, new volcanoes kept forming. Those volcanoes would release lava that would keep piling up, keep piling up, keep piling up, eventually go above the surface of the water and form this whole chain of islands. And as the whole Pacific plate kept moving to the northwest, it kept forming new islands. Now, the one question you might ask is, well, how come the big island is bigger? Has the plate kind of paused over there? Is it spending more time over the hot spot so that more lava can kind of form there to form this essentially it's an underwater mountain that's now also above the water. And actually, if you go from the base of the Pacific Ocean to the top of the big island of Hawaii, it's actually 50% higher than Mount Everest. So you could really just view it as a big mountain. But the question is, this looks so much bigger than Kauai, and they keep getting smaller as you keep going to the northwest. Is somehow the Pacific plate slowing? Is it spending more time here? And the answer is it's probably not slowing. What's happening is at one time, Kauai was also probably a relatively large island. If you rewind maybe 5 million years ago, Kauai also might have been about that big. But over 5 million years, it's just experienced a ton of erosion. Remember, once it moved over the hotspot, new land wasn't being created. It's in the middle of the Pacific Ocean. It's experiencing weather. 5 million years is a long period of time. And so it just got eroded over that time. So the older the island is, the more eroded it's going to be and the smaller it's going to be. So if you go to these underwater mountains up here that don't even surface above the ocean, at one time they might have surfaced, but over due to the ocean and weather and whatnot, they've just been eroded over time to become smaller and smaller kind of remnants of volcanoes. So anyway, I thought you would find that entertaining of how the Hawaiian Islands actually got formed and how we can actually have these hot spots and this volcanic activity and actually even earthquake activity outside of actually plate boundaries. Actually, while we're looking at this diagram, we talked about the trenches at plate boundaries. You can actually see it here because this shows the depth, and the really dark blue is really dark, deep parts of the ocean. So this right here is the Mariana Trench, and you can see over here the Pacific plate just getting abducted, or not abducted, getting subducted into other plates underneath and forms these trenches here. Anyway, hopefully you found that entertaining.